Okay, so let's make a start. So my name is Oscar Alvarado. I work in the powertrain manufacturing engineering division of Jaguar Land Rover. So I'm gonna talk to you about the same project, Prophecy, but I'm gonna focus on the use cases um, from Jaguar Land Rover. Yeah, let me move on, and then I'll just start to understand all the detail. So this first slide, I mean, just to show you what I'm gonna talk about throughout the presentation, but I don't want to spend much time here. So let me just move on, and then we'll go through every one of the points, so we can save some time. Okay, so I'm gonna start by giving you a quick overview of the project. As you can see on the left-hand side, this chart shows you basically what the integration of the platform looks like, right? So at the bottom, you have the end users, JLR and Philips, who presented their use cases a couple of weeks ago. And then you have the CPS systems or solutions, and then at the top you have the PDM, so ML toolkit, for example, and then all of this fits into the visualization solutions, right, like dashboards and AR. So that's just a brief explanation. I'm going to talk a bit more about this later on. So the CPS solutions or cyber physical solutions systems, what they do is collect the data in the field, right? So in the case of JLR, we have sensors that I'm going to show you later, collecting the data for predictive maintenance. And the solutions we use in the project adhere to the most popular 4.0 architectures, as you can see over here. And then we have the ML or machine learning, which is a toolkit for data management and analytics, and basically provides a library of machine learning and deep learning solutions. And then at the end, you have the AR, which is a solution that supports remote maintenance. It could be used for training and also commissioning, which is something that we're exploring as a JLR outside of Prophecy as well. And then at the end, you have the optimization engine, which is what Giannis just explained earlier, right? And then at the bottom, you have, for example, this the end user. So in the case of JLR, this is the machines that we apply the Prophecy to, and on the right-hand side, you have the Philips tools or tooling. So what is the motivation for JLR to do Prophecy? Just to quickly explain to you a bit of the background, this is the EMC plant or Engine Manufacturing Center at Wolverhampton in the United Kingdom, and this is what we build in the EMC plant, right? We assemble about 250 components, and we machine the three main or the biggest component, which are the cylinder block, cylinder head, and the crankshaft. So that's what we do in this plant at JLR. And the reason why we wanted to do Prophecy was because we wanted to predict failures in our process and prevent breakdowns. So, which is what you see here, right? We also want to reduce maintenance costs. So not just through the RUL or the calculation of RUL or the life of the tooling, but also through the use of AR solutions. And we wanted all this to obviously directly impact our key KPIs, right? So improve OE, like Kaldis, Giannis mentioned earlier, improve FTT, and again, I mean, see a direct economic benefit as well. And the second reason is as a strategic innovation step. This project aligns to our vision, basically to move from where we are at the EMC right now, which is a lot of preventive and reactive maintenance, which is basically we follow a lot of the estimation or suggestions from our vendors, and PROPHESY will help us move to the predictive phase of maintenance. I'm gonna just give you a summary of the use cases. There's 3 different use cases that we applied on PROPHESY. The first one is the application of PDM to our machine components. So in this case, on these slides, you can see one of the main components where we have a lot of, some of the most significant breakdowns, which is a new ball screw in our mag machines or CNC centers. So that's one of the use cases. The main issue on this specific use case that we found was the fact that we didn't have an automatic registration or collection of breakages, right? So we have all the signals coming from the sensors, but we didn't have breakages to tie them to, basically. So I'm gonna give you a bit more detail later. The second use case is very similar to the other one. It still applies to the mag machines or CNC machines. But this one focuses on the machining tools that we use in our machining operations, right? The difference here is that we do have a system that records automatically. It records the breakages on our machining tools, which is why throughout the project we basically made the decision to focus on this use case and then make it a success, and then apply the learning to the use case 1. This RT system or MARPOS system is the system that collects the data. But so basically, is the CPS infrastructure, the sensors that gather the data and collect it in our database for future analysis. And this system was installed about 5-6 years ago, and that was also one of the main motivations for the project, because we have this system gathering data, and we didn't think we know we're not using it to its maximum, let's say, potential, right? And which is a very nice proposition for this project. The third use case is a use case that focuses on the AR solution. So basically, we have our partner Oculavis, who have developed the shared platform for remote services, right? So through the use of this use case, we wanted, like I said earlier, to improve our machine, our MTTR and machine availability. So that was the main reason why we wanted to implement this use case, and I'll show you a bit more later. So I'm going to show you now more detail what we did on the main use case, which is use case 1, like use case 2, sorry, which is what I said earlier. What I said earlier is machine cutting tools. So we have this. This is just a part of our process flow at the EMC, where we have this is the machining process for our cylinder headline, and then these 3 operations, op 70, op 80, and op 90 are the main machining operations, right? So what we did throughout the project was to focus on op 90, which are pretty much the finishing operations, which is where we have most of the failures. And then these 3, what you see over here is you probably can't read it properly, but there's the 3 sensors that gather the data, right? So we have 2 torque sensors and 1 vibration sensors located in the machine collecting the data. And this is what it looks like, basically. This is our cylinder head, so that's what it looks like. Obviously, you can see there's a lot of operations. We focus on one specific one. I'll show you a bit more later. And then this is what the cutting tools look like. This is just 3 of them, right? But there's like 20. There's about 20 machining tools per machine, and we have over 200 mag machines in the EMC. And like I said, we have a spindle torque, spindle vibration, and Z-axis torque. These are the 3 sensors collecting the data. And then just to give you, I'm not going to go into too much detail here, but this is what the raw data collected by the sensors look like. And between JLR and our vendor technology provider, which is MARPOS, we did a lot of analysis of the data prior to sharing it with our data analytics partners, right? To make sure we were giving them meaningful data, right? So it was a learning process. At the beginning, we probably gave them a lot of data that wasn't very meaningful until we started to learn what to look for, right? So what it tells you here, the main things to look at is you have an indicator value here. You have a date, so that's very important. Obviously, the date, because you want to tie up this data with the breakages, right? So you need to understand when these values are being recorded. And then the indicators, there's a number of indicators. In this case, you see we're measuring the wear on the tool, but there's I think we have 15 different indicators, right? So the amount of data that is gathered by this system is massive, right? So this is just a short example for one of the tools, and then you have the number of the tool here. You also have these numbers here refer to one of the holes in the part, right? And I'm going to show you that in the next slide so you can understand it. And then you also have the machine where the operation is happening, so you can understand how you have to sort of tie up all this information with the breakages, but it will make sense, a bit more sense later. So this is what I was saying. You have the tool 4211 that we were showing earlier, and these are the holes that I was referring to. So 701, 7104, 7103, 02, and 01. So we are looking at specifically at this at the machine of these holes, basically, and the data I showed you earlier, that's what is being recorded, right? So you want to basically look for trends, create charts of this data, and then understand what the data is telling you, right? Then and then once you have those signals that from the machine, you want to overlay that with the breakage data. We have another system called SOLA, which records the breakages of the machining tool. So when you overlay the signals that I showed you earlier with the breakages, you have the date here, you have the number of the tool, which, by the way, it shows a different number here. So you need to also understand the mapping of the tools, right? The one system uses a different mapping compared to the other one, so you need to understand that as well. It's just an additional challenge in order to understand the data. And then when you overlay the two systems, then you can again, like I said, produce charts that show you the behaviors. So and this is what it looks like. These are when you create charts with the data. This is what it looks like. You start to notice trends, right? So, for example, you can see how the data, these red circles that you see here, is when we either change the tool or the tool breaks. So you can see how the data starts to behave very different towards the end of its life. So just to give you an idea of what it looks like. And this is what we achieved. Basically, we share a number of data from different tools with the data analytics partners. We looked at different machines as well. Again, this is a very simplified example, but we looked at probably about 60, 80 tools, and we looked into about maybe 30, 40 machines. And then we found some really good candidates that produce the best results, which was a 95% accuracy on the remaining useful life of the tools. So this is one of the main achievements of the project, that we managed to calculate the remaining useful life with this accuracy, basically. And this karma algorithm was developed by one of our data analytics partners, right? So it was compared to other algorithms from off-the-shelf algorithms that are out there in the market, and it was by far much better than those other algorithms. And something very important to mention as well is that, if you remember, all this data, all this analysis comes from an operation called OP90. After we achieved success on that operation, we decided to do the same on OP30, or at least start to produce some level of results on OP30, which is a separate operation, because we wanted to prove that we were able, it was feasible to expand or to replicate the results, right, as part of our future plans to expand Prophecy. And the next slide shows you the results that we achieved as part of the third use case, which is AR for maintenance. So we produced 3 different demonstrators as part of the project of the AR platform. 2 of them happen in the plant at JLR. I'm going to show you quickly, actually, just a quick video of what the solution looks like. So this video basically shows me giving instructions to our maintenance operator. This is what we demonstrated to the monitoring officer. What the maintenance person is doing here is he's wearing the AR headset in one, on his safety cap. So as you can see there, I'm giving them some instructions on on what to do, right? Remove these bolts here, and then I don't know, look behind it, and I'm just giving them several instructions, right? You cannot hear the sound in this video, but it's just to show you basically what we managed to demonstrate through the project, right? What I'm doing here is now taking a picture. That's why the image is still, right? And then I'm basically giving them some more detailed, instructions to say, remove these fixings, and then you have to look behind them. And then all this information is saved in this system called Ocularis Share, right, that I mentioned earlier. So that's what it looks like, just to give you an idea of what we did and how we demonstrated that we could use it, right? One of the main challenges was the Wi-Fi connection, right? So something that you need to take into account when you deploy this sort of solution, right? You need to make sure that your facility has that level or a level of good internet connection. And this is what the platform looks like, right? It can also store documentation. Like I said, it saves all the videos and photos that you take as part of the maintenance activities, right? So that's what we did on AR. The solution was very well received by both end users, and in fact we were taking this demonstrator and we want to replicate it in other areas of the business in JLR. Another outcome of the project was the RUL dashboard, which basically the dashboards are integrated with the RUL algorithms to produce the expected life of the tools that I showed you earlier. So this is what the operator is going to see, right? Once you integrate all the algorithms and the cyber physical systems, this is what the operator is going to see. They're going to see the machine number, the tool number, and then produce an RUL value for every one of the tools, right? And then it will give you an alert to say, this tool on this machine is going to break in, let's say, 50 or 100 parts. So we demonstrated that as part of the project as well. And we also have what we call the C dashboard, which is solution produced by Marpos. This is a solution that JLR already had implemented before the project, but the functionality was very limited. And what Marpos did was create some added functionality that basically lets you introduce limits, on the operation of the machine. You can tell the machine to basically stop or produce an alert when certain conditions are met on the operation of the tool. So you can define an upper and lower limit and basically monitor the condition of the machine remotely. And in terms of integration work, as I said earlier, we produce the data from our RT system that is stored in our local database at JLR, and we also have the tooling booking system that produces the breakages of that we can then tie up with the signals from the RT system and produce the data that we share with the partners. And then, so this is what you see in this lower part of the diagram, right, where JLR has this system called linear modular, which is what I showed you here on this side of the chart. And then that data gets shared through it gets shared through to the PROPHESY platform, to this GEM connector, right? And then you have all the cyber physical systems and PDM ML algorithms, as I said earlier, that then feed into the dashboards. So I'm not going to go into too much detail there. I think I already covered that. And as part of the project as well, we produce an expansion plan that basically we decided to look at the next 5-6 years and make a plan to say, okay, how are we going to expand PROPHESY to other lines or even other facilities within JLR, right? And this is what you see here, this Gantt chart. And some of the conclusion that we had is that it takes from 6 years to 1 year to implement the PROPHESY in one similar line. And then it takes from 1 to 2 years on a line that it might be completely different. Like, let's say, where you might have I don't know, a robot that produces different kind of signals. So yeah, that's what we. That's only some quick summary of what we achieved through this expansion plan. And we also produce a cost-benefit analysis that supports the expansion plan, right? That tells you that you have a business case to do it, which is what you see here and Giannis showed earlier. What this business case analysis told us is that over a period of 3 years, taking into account the costs and the benefits involved, you will see a positive return on investment, right? So it's not a quick win. That's one of the main conclusions that we have as part of the project. But if you have a vision or a strategy to look into 3, 4, 5 years, you can have a very nice return on investment after those initial 3 years. That's what we demonstrated here. And we also, as Giannis mentioned earlier, we also have gathered feedback throughout the project from the partners. We also gathered feedback from the end users internally, from JLR and Philips, and also from external organizations, right? So we produced 3 different reports that detail all this feedback, and some of the main points here to see is that we saw a very nice progression from the first version of the feedback, where we had a TRL level of about 4 or 5, to all the way to the end. At the end of the project, we achieved a TRL level of 6 or 7, according to the feedback we received, right? Which was the main target of the project. And the last slide, it just shows some of the most important conclusions that we have. So I'm not gonna mention all of this, but basically, as you saw earlier, we proved the application of PDM through the implementation of ML algorithms and the RUL prediction of our tools and machine components. We proved all the supporting we proved the viability of the supportive technologies like AR and the dashboards, as you saw. And we also concluded that some of the main challenges are the legacy systems that we have already in our plants, that some of them are really old. So it's very challenging to integrate them with a novelty platform like PROPHESY. And also we learned that another main challenge is to deal with the conflicting interests of the normal production, right? Where you're trying to implement an innovation project, and obviously the priority of the business will always be to prioritize the normal production, right? And the most one of the positives is, like I showed you, is the cost benefit analysis, that we prove that these solutions can be economically feasible, right? And the last point there, it says that there's a very good opportunity for us to do some future collaborations with our partners from PROPHESY or from the 4C cluster in the future to achieve further results. Yeah, if you have any questions, please feel free to ask, or you can see my details here. Yeah, if you can always contact me afterwards. I'm gonna now give the floor to Diego.
Yes, Oscar. Thank you very much for your presentation. You were saying people can address questions in our Q&A box, so I invite our audience to do that. I'm going to ask you like a follow-up just now. So you were asking about challenges and expansion plan. You mentioned legacy system as one of them. I don't know if you can tell us more on because it's been a very successful project. So if you have some ideas and the main challenge that you see for the future.
Yeah. So the problem is that some of the systems that we have in the plant, and I think it was the same for the other end user, Philips. We had some systems that were quite old, right? And it's been difficult to adapt those systems to work with the novel technology that we're trying to implement with PROPHESY, right? So it requires a lot of intervention from your IT teams internally, which might have other priorities as well. So everything is doable, right? You can do it with the right support. But yeah, it needs some level of commitment from the other areas in the business. I think that's the main challenge. There's nothing. We didn't find anything that couldn't be solved. But with the challenges that we have at the moment, with COVID-19 and other economic situations, in the current climate, it was difficult sometimes to get the right support. But yeah, it was good that we managed to produce good results as part, as part of the project.
Yeah, understood. Thank you very much again. Now we'll be also leaving the floor to Jeroen Versteeg, who is the last speaker of today, and then we can come back with questions from the audience if we have time. So Jeroen, when you want, you can also share your experience of FFT use case with us.